Hi everyone. In the given problem statement, we have to add two number. We are given two non-empty linked list representing two non-negative integers. The digits are stored in a reverse order and each of their nodes containing a single digit. Add the two number and return the sum as a linked list. So here, because the digits are stored in a reverse order, so our problem statement is simplified to a greater extent. Now let us take this example. Let's say 2, 4, 3, and let us take example of 6 perhaps, and we can have values of 5, 6, 7, and let's say here let us take a value of 4 for now. So we have to add the two values. So here we can have two pointers. Let's say this could be h1 and h2. So when you're at the first pointer, you're going to get the values. So our new pointer would have a value of 7. Now we are going to calculate the value of 4 and 6, which is 10. But in this case, right, so the value is 10, but the 0 would be added here and 1 would be a carry, which is going to get forwarded to out here. So here, right, the value would be again 10. So 10 plus 1, which is 11. So the value would be 1. Now, if I come back here, and there also we have a carry, so the entire value would be 1, and now we are moved to another position, but there are no nodes currently present, right? But because we have a carry, so we have to add that number to our end. So the value would be 70111. So that would be the idea, right? We have to just simply keep on adding those numbers, and in case you are finding an carry, move to the next one, and at the last, right, in case we have a carry at the end, right, and there are no nodes available, still we have to add that value to our new linked list. So this would be our new list. So that would be an idea. So we can have a for loop, keep on iterating until there are nodes in h1 or h2, or if there is a carry, and we can keep on writing this code. That would be a very simple code. Now let us jump to the coding part of it, which would require a little bit of complexities involved to get these numbers, but I'm pretty sure you'd be able to understand in a breeze. Now let us jump to the Python solution. The first thing that we're going to do, right, we're going to create a dummy linked list where you're going to store the addition of the value. So it will be dummy, and it would be having a value of list node to create our linked list. And we are going to assign our cur to our dummy. So cur equal to dummy. Now we are going to iterate through our loop. So while there exists an L1, or there exists a L2, or there is a carry. So initially, right, our carry would be 0, carry equal to 0. So basically it means, right, until you have end the end point of L1 or L2, or the carry is 1. Because if it's 0, it's not valid, right? So now let us take the example of val1. So val1 is nothing but L1 dot val if L1 exists, else you're going to add the val1 as 0. Similarly, val2 would be L2 dot val if L2 exists, else it is going to be 0. Now we're going to get the number. So number would be val1 plus val2 plus carry. Now our carry would become the number double divided by 10, and our number, we are going to take the ones place, so we can do it number equal to number percentage or remainder of 10. So we're going to get the 1 place value. Now we are going to add cur dot next equal to list node, and we can add our number to this value, and we can move to the next pointer. So cur equal to cur dot next. Now there are two more things. We have to also keep on incrementing our L1. So it would be L1 dot next if L1 exists, else it would be none. Similarly, L2 equal to L2 dot next if L2 exists, else none. That would be a simple code, and we are going to return our dummy dot next. Now let me run the code to get the solution. As you could see, all the public test cases passed. Let me submit the code. As you could see, it is beating 100% efficiency, which is wrong. It should be at least 1 millisecond. But anyway, our code is pretty efficient, and as you could understand, the time complexity of it is going to be big O of n. Now let us jump to the next solution.